Greetings, math fans. All right, so today's topic is called solving right triangles. Okay, and basically what we're doing is I'm going to give you some angles and I'm going to give you some sides. You're just going to be the rest of the sides and angles. It's as simple as that. Okay, so a couple things we need to talk about here first. Okay, so if I draw a nice little right triangle here, and I label those A, B, C, easy as 1, 2, 3. And basically your angles are always upper case letters. Okay? And your sides are lower case letters. Always got to remember that. It's really, really important. Okay, so again, don't come up to me and say, now is this a side or is it an angle? Because I'll tell you to go sit down because I just taught it to you. All right, so here's the deal, math fans. The side letters are opposite angle letters. And this happens a lot. Kids, I kind of even haven't marked my notes here. Kids get this wrong a lot. So that side, or that angle C, goes with little c. Okay, that angle B, again opposite, it's little b, and that side, or angle A, is little side A. Okay, just remember that. So opposite, the letters are always corresponding. So opposite C, little c, opposite angle A, little a, opposite angle B, little b. Okay? Okay, pretty easy, pretty easy. So let's just do solving some triangles now. And again, it's just the direction they're going to say solve the triangle. Right, and all these are nice little right triangles, which is very friendly. And I got A, B, and C. And this is going to be 3, 4, and that's what's given. Okay? And basically what you're going to do is you're going to say, oh, well, I'm going to put this section in red. Well, I'm going to put this in red. So this is actually given. So what you're trying to do here, math fans, is you're trying to use the information that's given as opposed to using calculated values. Okay, because what happens if you use a calculated value and you actually calculated it wrong, that's just going to compound the error. Okay, and you're going to keep making more and more and more errors because you keep using wrong stuff. So the deal is you always want to try and use the information that's given if you can. If you can't, sometimes you can't, then that's a different story. Okay, but if you can use information that's given to come up with the solution, that's what you want to do. So obviously the first thing you're going to do is I'm going to find side C, so little c, and you either know it's 3, 4, 5 triangles, so the answer is 5, or you use Pythagorean theorem. So either one of those two, but we do know it is 5. Okay? And now I need to figure out the angles measure of A and B. So let's do angle B. So the measure of angle B, how do we find that? Let's just put a colon here. How do you find that? Well, what we're going to do is we're going to use trig. Okay, we're going to use our nice little inverse trig functions to find values of angles. And so if you remember, again, it's using, this is really important, so ka toa. Okay, and which ones are going to, which trig function uses the opposite and adjacent? So that's basically the 3 and the 4. Well, the only one that does that is tangent. All right, you're not going to use the other ones because the other ones actually use the hypotenuse, and we actually used, we calculated that 5 using Pythagorean theorem or 3, 4, 5. So if we made a mistake and we said it was a 3, 4, 7 triangle for some reason, and then we use that 7 in the equation, you're going to get it wrong. Okay. So what I'm going to do is I'm going to say tangent of big B equals opposite over adjacent. All right, and then when I want to find B, I do the inverse tangent of that 3/4. Okay, make sure when you type in your calculator you close the parentheses, and you use your inverse tangent button, right? Second tangent. And if I actually round to the nearest minute, you guys can actually do this while I'm doing it, but it comes out to be 53 degrees 8 minutes. Okay, and then measure of angle A. Now again, the best way to do this is actually you want to do tangent again. So tangent of A is equal to opposite over adjacent. So angle A equals inverse tangent of 4/3. So measurement of angle A, gives you 36 degrees, 52 minutes. Now so basically we solved everything. So we have, let me just highlight this, we have C is 5, we have B is 53 degrees 8 minutes, and A is 36:52. Okay, it's a good idea to make sure, of course, A and B add up to what? They need to add up to 90 degrees. Okay, it's very important. If they don't add up to 90 degrees, the triangle's got to have 180 degrees, and it's already got 90 at angle C, and so, just got to make sure, it adds up correctly. Now, I think, would I have done it this way to get angle A? Maybe. Truly, I know it's 90 minus 53 degrees 8 minutes, and I probably would have done this. And I'm not going to mark it wrong if you use a calculated value, but I'm just warning you that if you use a calculated value and it is wrong, you're just going to compound your error. Okay? So, I probably would have gone this route because it's not necessarily a really complex calculation, and that one kind of works out pretty well. But this also works just as well, right? Using the tangent of theta, or of A is equal to 4/3. Okay? All right. So let's try another one here. Again, this is going to be solve a triangle. And I'll give you some information. And this is our A, B, C with a right angle at C. This is 6 centimeters. And this is 50 diggity. Okay, so how do you find, the first thing you're going to do is you're going to find angle A. That's easy. It's just 90 minus 50, which is 40 degrees. Okay, so that's pretty easy. And then let's find, we got little a and little c to find. So let's find side A. And how am I going to find side A? Well, again, I'm going to try and use the information that's given. So I'm going to use, well, let's kind of highlight this, right? I'm going to use this, one of these, hopefully both of those things here, and I certainly can. You're going to say side A, I'm going to go a tangent of 50 degrees, because tangent uses opposite and it also uses adjacent, okay? And the only thing that's missing here is the adjacent, so that's what we're figuring out. So tangent of 50 equals 6 over A. And then we cross multiply and we get A tangent of 50 equals 6 divided by tangent of 50. So 6 divided by tangent of 50 gives me 5.03. Now if you would give me that answer, I'd actually take 1 point off. Boo! Why would I take 1 point off? Because you need your units. Okay, units. Very, very important. Okay, now to find C, again, I could use Pythagorean theorem, but I would almost advise not doing Pythagorean theorem now, especially this is rounded. Now if you kept, instead of saying 5.03, you had 5.039765, you had the whole thing, then you'd probably get somewhat reasonable of an answer. But for now, why not just, I'm looking for, again, side C. Side C, why don't I just use trig again? Okay, and so side C, again, using that 6 and that 50 degrees, what trig function are you going to use? Well, 6 is opposite of this, right? So I can use opposite, and I'm looking for hypotenuse. So which one's opposite and hypotenuse? It's sine. So sine of 50 degrees equals 6 opposite over hypotenuse. We'll see. Okay, you cross multiply and you get C sine of 50 equals 6 divided by sine of 50. So C comes out to be 7.83, and again, don't forget your units. Okay? Not bad. It's really pretty easy. Alright, and then the next example here for solving, again, so I'm going to say solve the triangle. And This is what you're given. So this is 8 kilometers and 5 kilometers, and this is A, B, and C. Okay, so of course, how do you find little b? You find little b by using Pythagorean theorem. So b squared equals 8 squared minus 5 squared. So b squared equals 64 minus 25. So subtract, and you get b. So b squared is equal to 39. Take the square root of both sides. And again, please don't give me plus or minus. You know better. Lengths can only be positive. So you get 6.24 kerfometers, kms. Okay? Now let's do a measurement of angle A, just for the heck of it. So angle A, we're going to do, now again, which one uses these two values? I don't want to use B. Which one uses it? Well, opposite and hypotenuse. So opposite and hypotenuse is sine. So I would say sine of A is equal to 5/8. And then I do inverse sine of 5/8. And that gives me angle A is equal to 38 degrees 41 minutes. Okay? And then I could, it's not a bad way to go about doing it. I could say 90, so this is angle B. I could say 90 minus 38/41. Okay, again, there's always a risk. So yeah, I could do that. I mean, truly, if you subtract, you get 51 degrees 19 minutes. But the way I can do it, I can also say measurement of angle B, and that would be cosine of B, right? Because cosine of B is adjacent over hypotenuse. So cosine of B is equal to 5/8. And I do B is equal to inverse cosine of 5/8. And you put that in your calculator, and you get angle B is equal to 51 degrees 19 minutes. Okay? So anyway, that's it, math fans, for solving triangles. Really pretty easy. I gave you guys 3 examples, and hopefully you guys are good to go with this. And just again, don't use rounded values, and don't use calculated values either, and you should be good to go. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye. Okay, so that's pretty much it with solving right triangles. So let's go to our next part here. All right, so our next topic is angle of elevation and depression. Really don't like talking about this topic because I don't mind the elevation, but the depression is just so sad. Okay, if I could rename this topic, it would be called angle of elevation and happiness, and then everyone's happy and there's no crying. All right. All right, so the main thing with this topic, math fans, is you always draw from the horizontal line. I cannot stress that enough. Okay, I'm going to highlight this. Always draw from the horizontal line. That is so critical. Right? So let me just really quickly explain this. Here's the horizontal line, and this is the angle of elevation. So it goes up because it's elevating, you go up. And then angle of depression is always, again, from the horizontal line going down. So it's angle of depression. Okay, but always from the horizontal line. Again, I cannot stress that enough. That's probably the #1 mistake. Is I see kids, when I say angle of depression, sometimes they go from this distance, this angle right there. This is so wrong. I'm going to put a red X through this. Okay, don't do that. All right. All right. So let me just give you an example here. If I told you the angle of depression from the top of a building to log E, which is a little log sitting down on the bottom of on the ground someplace, that angle of depression is 30 degrees. And the height of the building is 100 meters. The question is find the distance from log E to the base of the building. So this is the deal. Here's your building, and I would always recommend whenever you draw a building, don't draw like a fancy building with, you know, two-dimensional everything. Just draw a line, a vertical line that represents a building. And then if I told you that the angle of depression from the top of the building to log E, so what you're going to do is you're going to draw a dotted line. And this is the angle of depression going down. So this is, again, I'll just draw a little thicker. So this is our building. And this is, on the ground here, this is log E. So we're going to draw a log. Okay? And angle of depression, if I said it was 30 degrees, it's this angle right here. Okay, not this angle. It's the number one mistake. It happens every single year where kids, I get a couple kids that they just don't listen. And they just draw it from, they draw it from the vertical line. Okay? This is so wrong. Don't do this. Don't do that. Okay? So, let me actually erase that. Okay. So we have that 30 degrees, and again, whenever I want to mention this again, whenever you're drawing a building or mountains or anything that's like has a height, just always draw a vertical line. Like a tree, don't draw a tree, just draw a vertical line. Okay? So anyway, the kids kind of get this confused too. If I say find the distance from log E to the base of the building, guys, the base of the building is in the bottom here. That's the base, not the top. That's the top. The top is the height. So really, here's your triangle. Here's your right angle, and I want to find this distance x. Okay. Now, what can you do with that 30 degrees? Well, I could, if I wanted, I could make, since this is 90 degrees here, I could put this angle inside the triangle and make that 90 minus 30, which is 60. Okay. It's okay to do that. So, but I'm going to erase this. Okay, what I would rather do is you to understand if that's 30 degrees, this is also 30 degrees. And why is that the case? Because what can you tell me about this angle and this angle? Well, first of all, this line right here and this line right here, aren't they parallel lines? Because again, they're both horizontal lines. And if you have a line going between those, the transversal, what can you tell me about these two red angles? Well, they are alternate interior angles. And what can you tell me about alternate interior angles? They're congruent. This is kind of nice. Again, you could say that angle on top there is 60, which would be just as fine. But I think knowing that these angles are alternate interior angles and they're congruent is perfect. Because now I can transfer that 30 degrees inside this triangle. Okay, and I didn't mark this yet, but this is 100 degrees or 100 meters high. So all you need is one angle on one side, guys, and then when I'm looking for x, it's easy. So remember, what trig function am I going to use? Well, I have this right here, and I'm looking for x, and I have this angle right here. So which one uses, this doesn't use hypotenuse here. So I'm using opposite, and I'm using adjacent, so I'm going to be using tangent. So tangent of 30 degrees equals opposite 100 over adjacent over x. That's it. Okay, and I cross multiply, I get x tangent 30 equals 100 divided by tangent 30. So 100 divided by tangent of 30 is 173.2 meters. Okay, so that's how you do that problem. But remember, from a horizontal line. All right, and then the second problem that I have here, let's clear this out of here, is basically I have two buildings. One short, one tall. Okay, I'm going to use AOE for angle of elevation. Angle of elevation from the top of the short to the top of the tall is 20 degrees. And the angle of depression, AOD, from the top of the short to bottom of the tall is 35 degrees. Okay, and then I tell you the height of the small building is 50 meters. And my question to you is find the height of the tall building. So basically this is what you have. Let's just draw a nice little picture here. And that's like actually key. So you have a short building and you have a tall building. And here's your ground, which makes a nice perpendicular. Then let's read what we have here now. The angle of elevation from the top of a short building to the top of a tall is 20 degrees. So again, put your dotted line in here. So angle of elevation from the top of the small to the top of the tall is 20 degrees. Okay. The angle of depression from the top of the short, which is the left building, to the bottom of the tall, or I could say base if I wanted, is 35 degrees. So again, it's this way, and this is 35 degrees. Okay, and then the height of the small building is 50 meters. So I'm going to put 50 here, which just means this is 50 right here. Okay, and that's all you're given. So here's the deal, math fans. I really can't do anything with the 20 degrees right away. Okay, so what I want to do is I want to calculate something. I've got the 35 degrees and I got the 50. Well, what are you going to calculate? Certainly not going to calculate, you know, a height or this. It doesn't make any sense to calculate this hypotenuse here, right? Because that doesn't do any good. What actually does make sense is to calculate this value right here. Because once I calculate that, then I can go, I'm really looking for this, math fans. I'm looking for x, because once I have x, I add it to 50 and I get the height of the tall building. Okay? So if I'm looking for that red line, do you guys agree that I have 35 here and I have 50 here, 35 degrees? So what uses the 50 and the red line? Well, it's tangent again, okay, because it's not a hypotenuse. So I can say tangent of 35 degrees is opposite over adjacent, which is we're going to call this y. We'll call that y on there, okay? And then let's cross multiply, so y tangent of 50, or 35, sorry, equals 50. Divide by tangent of 35. So y equals 50 over tangent of 35, which is 71.4. 71.4 meters. Okay, so now I have y, and I can go to the top triangle. And I can say, I've got y, and I have 20 degrees, and I need x. So again, there's no hypotenuse, so I'm using tangent again. So tangent of 20 degrees equals x over 71.4. Now I rounded that, and you're not going to round it. You're going to keep that in your calculator, because what I'm going to do here is if I multiply, I get x equals, cross multiply, so 71.4 tangent of 20. So truly what you're doing is your last answer that you got was 71.4, blah, 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 blah. So you're just going to hit times tangent of 20. Because you never use a round answer for when you're doing anything here. And you get y equals, or x equals 26.0 meters. Okay, so that's pretty easy, 26 meters. And so then the total height, of course, is the short building plus that part on top. So let me move this down a little bit. So it's basically going to be 50 plus 26, which is 76 meters. Don't forget your units. Okay, so that's this whole height right here. Okay? So anyway, that's it, math fans. Hopefully, you learn a lot about solving right triangles, and also with just doing angle of elevation, angle of depression. It should be pretty easy. Okay. So that's it, math fans. Have an outstanding day. Adios. Goodbye.